After watching this video, you'll be able to describe the problems with the waterfall method and describe the typical relationship between software development and operations prior to DevOps. It's important to understand what brought us to DevOps in order to fully appreciate the problem that it solves. Architects would spend months and months designing the system on paper, creating requirements documents, creating design documents, making high-level designs, low-level designs, system-level designs. Then, finally, we get to the development phase, where development worked for months and months on features in an isolated development environment. As they developed the code, if the designs are wrong, it was very expensive to go back to the architects. Once we developed all the code, we'd get to the testing phase, and we'd test all the code at once. And testing would open defects, send the code back to development until no more severity 1 or 2 defects were found. At some point, development would release the code to operations for deployment. This release to deployment would happen several months after the code was written, maybe even a year later. Some of these projects took up to 2 years. Then, the operations team would take what seemed like forever to deploy it because they had no idea what the developers had built. An operations team kept running it from that point on. We call this way of working the waterfall method. With waterfall, everything happens in phases. Requirements are gathered, and a requirements document is generated. Then that phase ends. The artifacts for that phase flow down to the next one. In the next phase, we do all the design, and the design is documented in high-level designs, low-level designs, system-level designs, and that phase ends. Those artifacts get passed down to the next phase, and the coding begins, where developers take those low-level designs, the design documents, and write the code that implements those designs. There are entrance and exit criteria to each of the phases. So all along, we're coding in isolation. We're not integrating my module with the next person's module. Finally, you get to the integration phase when all those modules come together. This is the first time we realize we don't know whether all these pieces even work together. And then we move on to the testing phase, because now we've got a system that people can test. And as they find bugs, they must go swim back up the waterfall and open some bugs in the coding phase and do some recoding. Finally, after all that testing, we deploy the software. It's called waterfall because if there's a problem, it's very hard to go back, like trying to swim up a waterfall. You have to go all the way back to the design phase. In fact, because we treat software development like civil engineering projects, sometimes those designs have moved on, right? The architects moved on, the designers moved on to the next project, and you've got to go find them and get them to change the design. Then you get the developers to change the code in hopes that it integrates this time. This process was very error-prone, and there was no room for making changes late in the process. You didn't know whether it worked until the end, so it was very high risk. But we developed software like this for years. So what's wrong with this approach? Well, there's no provision for change. Every phase has entrance and exit criteria. When one phase ends, the next one begins. And there's just no provision for going back and changing the design or changing the requirements or anything like that. Another problem is you don't know if it works until the end. There is no intermediate delivery. Nothing is delivered until that last step when we give it to the operations team and say, go deliver the thing to production. In addition, with each phase, there are issues that are just passed down. And of course, every one of these is an opportunity to lose information and to have a mishap. People get blocked because they can't accept the work from the previous phase, and then the next phase is delayed. Mistakes that are found later are very, very costly. It's especially costly to find something that's in design wrong in the testing phase and then go all the way back and redesign it. Finally, these delays create long lead times between deliveries. Also, the overall problem with Waterfall is that the teams are working separately. They're unaware of their impact on each other. Designers are unaware of the impact of the code. The coders are unaware of the impact on testing or impact on integration before we get all the code together. So everybody's working in their silos for their phase. And the scariest thought is that the people who are furthest away from the code, the poor operations team, have to deploy it and run it and manage it in production. They know the least about the code, and they're the ones expected to run it. In this video, you learn that traditional waterfall development creates problems such as delays, frustration, long lead times, expensive late changes, and operations managing unfamiliar code. and that in the past, software developers and operations worked in silos rather than working together.